The following content has been provided by RWTH Aachen University.
When I said Apple, pretty fast you had your concept in your mind. You knew what I was talking about. Some had different concepts about, well, but whatever works. But it's really slow to write there. So you have to remember it more often, or you have to build your little bridges to remember something. And for this model, they tested and figured out that it's roughly that you need 7 seconds to remember a chunk if you just use one pass there. So it takes a longer time to get stuff in than getting stuff out. So this then deals with the cognitive processor, and which is responsible for fetching your information and storing them away in a way. And now let's look at the motor processor. And for that, experiment time again. On the bottom you have 2 lines that are 1.25 centimeters apart. Now I want you to take out a pencil, and I'm then giving you 5 seconds to scribble between these lines. It should look something like this. So go as fast as you can. Try to get to the lines. And 1, 2, 3, start. And stop. So now you all should have something like this. And now I want you to count the number of reversals that you have. And since you're all computer science students, know how to do this logically, just count the number on the top and then, take it times 2. So in this example, we had 34 reversals on the top, so 68 reversals overall. Write this down. Then we'll do this in a minute. Then create a contour on the bottom. So sort of how far did you go? Where did you draw shorter lines? Or where did you overshoot? Draw this contour on the bottom. So along the lines. And then count there the number of the corrections that you did. So where did you realize, well, I'm going too slow or too far, I have to correct it once more. So all the tips of your contour, so to speak. And note this down as well. Take it times 2, so you have a rough estimate for the corrections on the top as well. So in this case, 10 corrections down here. So I count down or note down 20 corrections overall. About the number of reversals, just tell me the numbers that you, how many you had. 90? Mm-hmm. 90, well, that's not correct. Yep. 46. 66. 26. 52. 54. 64. 64. And 56. 26. Okay. Then now for the number of corrections. Let's do the second row. 12. 10. 30. 15. 22. 17?
5.
5.
13.
There's 13, and the 4? Oh, okay. All right. Then a couple of more in the... Yes? 4? 12. And 26. All right, just let's stop there. Now I can't read that. If we take the median of these numbers, then we get to a number for milliseconds for the reversal. So how long did it take until the next line came along is something around 90 milliseconds per reversal. And for the number of corrections, we're here at around 384 milliseconds per correction. And let's start this up again. Because what we did there was look at the motor processor. And let me just switch to the next slide there. So with the data that, or the example data was 74 milliseconds per reversal and 250 milliseconds per correction. And that, of course, differs. When you're very good, you almost have no corrections. So then the number here goes up. But in regular, you tend to arrive something around that. But we'll look at that. So just for the reversal, was basically, you didn't have to think about that. It was just scribbling along. It was just the motor processor telling you to draw, 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 turn around, turn around, turn around. And in their studies, we've seen that there's this roughly around 70 milliseconds for each reversal. And so with the basic numbers we had here, we were 90 milliseconds, so not that far off. And this is sort of an open loop because you're not correcting in any way. You're just drawing. And yeah, there it takes around roughly 70 milliseconds to do something. The corrections are more a closed loop because you're seeing what you're drawing and interpreting that, and then correcting based upon on the thing you see there. So it is that you first perceive what happens. This goes then into your visual store to the cognitive processor that decides, well, do I have to correct? Is everything still fine? This then goes on to the motor processor, which tells the arm to, well, don't move that far or move further on. So this is then a closed loop. And so you have to add up all the processing time, the cognitive time, and the motor time, which goes roughly to 240 milliseconds in their experiments. But yeah, as we've seen, it also goes up since these are only estimates that have been made over with a lot of participants. So that is the average time that you have between each of the corrections. And this, overall, since we have this now, this allows you to answer the question, well, if you're in front of a button and I'm flashing a light at you and you should press the button, how long does it take? Or what can you estimate how long it will take? Because it's perceiving the light flash, recognizing that it happened, remembering, well, I should press the button, and then pressing the button would take roughly around 240 milliseconds.
This content was provided by RWTH Aachen University.